again, I would put this on the card, but if you do enough practice, you'll get what to do for this. So I know he did it in a different order for the first two. He said leave the bottom alone, then the derivative of the top. I, again, like it like the product rule. The derivative of the first, leave the second one alone. This one's a subtract for the quotient, though. Leave the first function alone, this derivative of the second, and then the whole thing. And this is where people forget. They forget that they have to divide the bottom by the bottom squared. So some people remember it by mnemonic. I never did. I just did f prime g minus f g prime all over g squared. But there is a saying, you can Google it and find all these people singing and stuff like that. Low d high minus high d low. What does that mean? It means leave the low function alone, and then you find the derivative of the high one. Do you see? Minus d low. That means the derivative of the lower one over the denominator squared we go. Anyways, so it's up to you how you want to memorize this. Again, if you Google quotient rule, there's a whole bunch of people figuring out a mnemonic to memorize it. In the end, you just have to know it. So, all right. Let's try the first one then. Okay, so find the derivative of the top. What is that? What's the derivative of x squared plus 1? 2x. Leave the bottom alone, so x squared minus 1. Subtract. Keep the top the same, so x squared plus 1. Find the derivative of the bottom. What's the derivative of the bottom? 2x. Then we have to take the bottom and square it. X squared minus 1, the whole thing squared. Done. No.
Really?
Done. So this is actually pretty easy once you know what to do, right? Like, it's really fast, really easy. So let's go on to the next one. F prime t, find f of t, find f t prime. Now the thing about this one is we should rewrite this as x to the power a half before we start, right? Okay, so do you want to try it by yourself? Yeah? Okay. So try it yourself. Just so you know, this doesn't make sense that this is a t and this is an x. This should be an x in here and this should be an x there. Because otherwise it doesn't make sense if you're finding the derivative with respect to x, not with respect to t. Yes?
When you're writing on your f of x for the second part, does it matter which one you do those x to the power of a half?
Good question. No, it doesn't matter. Yeah. So derivative of the first would be 1/2 x to the power negative a half times the second one left alone. Subtract, again, make sure you remember it's subtract. Some people always put plus because of the product rule, but it's not the product rule. Then you leave the first one left alone. So here's the thing. You can write it as x to the power a half, or you can write it as the root of x. It's up to you. And then the second one is just 2, yes? And then the bottom is 2x plus 1, the whole thing squared. Everybody good? Easy. Keep going. Okay, so now we're going to actually solve some questions involving this. It says find the equations of the tangent line and the normal line to the curve y equals the root of x over 1 plus x squared at the point 1, half. So in order to find the equation of the tangent line, we need the slope. We already have the point. We have the point 1/1/2. We need to know what the slope is. So how do we find the slope? We find the derivative. Then we sub her in to get what the slope is, right? So first we need to find y prime. Does everybody see that? Again, this right there is x to the power a half, right? So I'll give you a second to find the derivative of that quotient. So derivative of the first one is 1/2 x to the power negative a half times the second one left alone. Subtract the square root of x times 2x, yes? All over 1 plus x squared to the power 2. So this is now the derivative at any point, right? If I want to find the slope, I need to find a slope at a particular point. At this point, it's 0.1. So the slope when x equals 1, you can put there just so you know that you're doing that. So I'm subbing 1 in for all the x's here. Does everybody see that? The y prime is getting replaced with m because I'm now substituting it in. So this is the square root on the bottom of 1, which is still 1. And so then I get what? A half out of that. Then I get 1 squared, which is 1. 1 plus 1 is 2. Minus the square root of 1 is just 1. Times 1 times 2 is 2. All over 1 squared is 1. 1 plus 1 is 2. And I get 2 to the power 2. Is everybody good with what I did there? So then the 2's cancel there. I get 1 minus 2 divided by 4. So I get negative a quarter out of this. I'll give you a moment to see if you can get negative a quarter because I probably did that really fast. So I'm not done. All I did was find the slope. So now I want to know the slope of the tangent line. So here's this. Sorry, that is, I want to know what the tangent line is. This is the slope of the tangent line. So remember we're putting it into point slope form. So y minus a half equals negative a quarter x minus 1. Done. You can move the half over and simplify for sure. Again, if this was on a multiple choice, it might be simplified, but the only requirement is coming up with the equation. So I would probably stop there and get the right answer and full marks, because if you move stuff over, you run the risk of making a mistake. So what do we do with the normal line? That's the perpendicular slope, so still going to be y minus a half, but instead of negative a quarter, it's going to be 4x minus 1. Done. Okay, so the product rule can continue. So if you have 3 things multiplied together, you just find the derivative of the first, leave the 2 alone, then find the derivative of the second, leave the first and the third alone, etc., etc., etc. It's just a pattern that follows. So let's try it. Y prime equals, so we find the derivative of the first. What's the derivative of the first thing? 1. Then we leave this alone. Plus, we leave the first alone, x plus 1. Find the derivative of the second. What's the derivative of the second? 2x. Very good. Leave the third alone. Plus, now leave the first 2 alone. So it's going to be x plus 1, x squared plus 1. Now we're finding the derivative of the third. What's that? 3x to the power 2. We're done. Beautiful. Uh-oh. What do we do in example 4?
Quotient.
So, there's a quotient rule. However, the top has a product. So, not only do we have to do the quotient, but we have to do a product at the same time. Okay, so that's okay. So, it's not as hard as you think. You just have to keep track of stuff here. Okay? So I'm going to label this top and this bottom. Does everybody know that y prime is going to equal the derivative of the top times the bottom, subtract the top bottom derivative, divided by the bottom squared? Does everybody agree that that is true? Okay, now here's the thing. The top derivative is the only problem that we foresee. Why? Because it is a product. So when we do the top derivative, we have to do the product rule. Okay, so let's try it. Y prime. Top prime is a product rule. How do we do the product rule? It is the derivative of the first, which is 3x squared. Leave the second one alone. Plus, I'm still doing the top derivative. Does everybody understand that? So now it's x to the power 3 And then we're finding the derivative of the second, which is 1. Now, because this is an addition, and we're taking that whole top derivative and timesing it by the bottom, what do we need? Brackets around that. Now the bottom is going to be x cubed plus 2x plus 1. Bracket, subtract. Now it's the top, left alone. I'm going to run out of room here. X to the power 3 times x plus 1. Yes? So that's the first one left alone. Then it's the bottom derivative. So what's the bottom derivative? 3x squared. What else? Plus 2, right? And then the whole thing is divided by the bottom squared. So that would be x to the power 3 plus 2x plus 1, the whole thing squared. Does everybody see that? Okay, horizontal tangents. Some of you that have done your homework have already figured this out because they asked a lot of horizontal tangent questions. What do we know about horizontal tangents? The slope is 0. A lot of them in the past, because we didn't know this rule, was they asked you quadratics, and the slope is 0 at a max or a min, so it was easy to find because you just have to find that max or min. However, now we're getting into the good stuff. So, if I want to find where the slope is 0, how would I figure that out? Set the derivative equal to 0 and solve. So let's do that. First we have to find the derivative. So y prime. What's y prime equal to? 4x to the power 3. That's it? Minus 4x. And the 2 goes away, right? Okay, now I'm going to set this equal to 0 and solve. So I get 0 equals 4x cubed minus 4x. How do we solve something like this? This is grade 12 pre-cal now. What do we do? Factor out not just a 4, but a 4x. So we're going to factor out a 4x, and we're left with x squared minus 1. Which is difference of squares. I'm going to go back up here. 0 equals bracket 4x. And what does that become? Yes, x minus 1, x plus 1. So, what is my x points? Not just 1 and negative 1. 0, 1, and negative 1. It's asking for the tangent points. Are these points? No, they're just the x values. So therefore, points at horizontal tangent are 0, comma, nope. What's f of 0? 2. You plug 0 into here and you get 2 out of this. 1, comma, what's 1 minus 2? Plus 2 is 1. And negative 1, put it in. So, higher order derivatives is basically just finding the derivative over and over and over again. So, we are going to find the derivative of this 4 times. So what's y prime equal to?
15x squared minus 4x.
15x squared minus 4x. What's y double prime? Meaning find the derivative of that.
30x minus 4.
30x minus 4. Because the 2 gets multiplied by the 15 and then you subtract 1. Y triple prime. Does everybody see it's going to be 30? And what's y to the power 4? Usually we just put a little 4 like that, by the way. It would be 0.
Yeah, but doesn't that look like, you know...
Actually, the way they do it is they put it in brackets like this so that you know it's not a y to the power 4. Okay, here's something nice. They actually like asking this in the multiple choice and stuff on the AP exam. So they give you information here. Okay, so here's a lot of the times what they do is they give you the information. So they don't give you what the function is. They just give you all the values and they say find this. So what they're saying here is this is a product derivative when x is 2 or when the x value is 2. So the way you do this is, does everybody know, forget about the 2 for right now, does everybody know that u v prime would be, this is a product, so u prime v plus u v prime. It's the first function derivative times the second one left alone plus the first function left alone times the second derivative. So now this would be the same thing but at 2. So this would be equal to u prime at 2 times v at 2 plus u at 2 v prime at 2. All I'm doing is now I'm putting in the 2 value for the x. So what's u prime of 2? It says it right here. U prime of 2 is equal to -4. So I'm going to put it down here. So -4. What's v of 2? It says right here, 1. Plus, what's u of 2? 3. What's v prime of 2? 2. What do we get? -4 plus 6 is 2. So we'll have a multiple choice and all you'll see is the answer is 2 or whatever, and that would be how you do it. Okay, how would we do this? So this is the quotient rule. Again, if I were to do this without the 2, u over v prime would be u prime v subtract, right? u v prime divided by v squared. Yes, so now we're going to have the 2 in there. So u prime of 2, v of 2, subtract u of 2, v prime of 2, all over v of 2, the whole thing squared. So what is u prime of 2 again? -4. So -4, what's v of 2? 1, subtract u of 2, 3, times v prime of 2, 2, divided by, what's v of 2? 1 squared. So then we get -4 minus 6 divided by 1, which gives me -10. Final answer. All right, and we did